All right, so this is we'll call it Chapter 10 supplement. And we're going to talk about trig identities. So the first one we're going to talk about is what we call the tangent identity. So we're going to draw a triangle. We're back to working with a right triangle. The law of cosines works for any triangle. So we're back to working with a right triangle. And we'll do a little bit of, this will help us review a little bit. So we're going to label the sides of this triangle. The hypotenuse, longest side across from the 90-degree angle, we always call it the hypotenuse. So I'm going to call that the hypotenuse. Which side is this, opposite or adjacent? If this is our angle, opposite. And so this side is the adjacent side, next to the angle. Hypotenuse is always the hypotenuse. So we're going to write out our ratios for tangent, sine, and cosine. So tangent theta, remembering SOHCAHTOA, is opposite over adjacent. And we said that sine of theta is opposite over hypotenuse. And cosine of the angle is adjacent over the hypotenuse. So these are our ratios. This is how we come up with our ratios from our sides. So way back to the beginning of our chapter. Now notice that in the sine and the cosine of our angle, a hypotenuse is in the bottom of our fraction, and we have opposite on the top and adjacent on the top here. And our tangent is opposite over the adjacent. So we're thinking that these sine, cosine, and tangent are going to be related somehow. So what we're going to do is make a fraction out of sine theta and cosine theta. And we're just going to write them with how we define them with our triangle. So this is the fraction opposite over hypotenuse divided by the adjacent over hypotenuse. So we're dividing a fraction by a fraction. When we divide a fraction by a fraction, dividing a fraction by a fraction is the same as doing what with the fraction? Multiplying by the reciprocal. And if you remember, I don't know if some of you might have learned it, copy dot flip. So you copy the top, you write a dot for our multiplication, and then we flip the bottom. So dividing by this fraction is the same as multiplying by its reciprocal. Well, now I have the hypotenuse, whatever that is, it's just a number, divided by the hypotenuse. What's any number divided by itself? 1. So if I divide something by itself, I get 1. These cancel. And I can rewrite that fraction as opposite over adjacent. So what this tells us is that sine theta over cosine theta, what fraction is opposite over adjacent? What trig function does that tell us? Opposite over adjacent. You wrote it right here. Tangent. Sine theta divided by cosine theta equals tangent theta. So this is our tangent identity. And this is probably one of the most important identities in not just in trigonometry but in all of math. This identity shows up in all kinds of places. For any angle, the sine of the angle divided by the cosine of the angle equals the tangent of the angle. So this is true for any angle in a triangle. Sine of theta divided by cosine theta equals a tangent of theta. And that just comes from writing sine of theta and cosine theta as a fraction and working with that fraction. So questions on what we did here. So let me show you an example of how we might use this identity. If sine theta equals, let me come up with some numbers here. Is 0.423. And cosine theta is 0.906. Find the tangent of theta. So we know the sine of the angle, we know the cosine of the angle. Well, our identity tells us that tangent theta equals sine theta over cosine theta. So tangent theta equals 0.423 divided by 0.906. And I plug that in my calculator. And I get 0.4667 or 0.467. So the tangent of the angle is the sine of the angle divided by the cosine of the angle. And that's true for any angle. Questions on that example? So this is really a very easy example of how we use this identity. When you go further in math, you'll do a lot more with this identity. And I'll do another kind of example a little later, but we need to learn one more identity. So our tangent identity says that the tangent of theta is sine theta divided by cosine theta. The next one is called the Pythagorean identity. So let's draw a triangle again. And we're talking about a right triangle. So here's our angle. Here's our 90-degree angle. And I'm going to label the sides A, B, and C. So this is the right triangle. What does the Pythagorean theorem tell us about this triangle? What does the Pythagorean theorem tell us? A squared plus B squared equals C squared. We know that's true for a right triangle. We know that the sine of theta, let's label our sides. This is the hypotenuse, this is the adjacent, and this is the opposite. The sine of theta is the opposite over the hypotenuse, A over C. Cosine of theta is adjacent over hypotenuse, or b over c. So what we're going to do is we're going to square both of these and add them together and see what happens. So I'm going to write sine theta squared. If I square that, I get a over c squared. Cosine theta squared is b over c squared. Now another way that we write sine squared is this is the same as writing, just so you know it when you see it. We put the square right by the sine. So this sine squared is the same as squaring whatever the whole thing is. And this would be the same as cosine squared. Normally you'll see it like this. So we're squaring the whole thing. This is what this is telling us. All right, so we're going to add these together. So I'm going to say that sine squared theta plus cosine squared theta is a over c squared plus b over c squared. If I square parentheses, I'm squaring everything inside the parentheses. So I can write this as a squared over c squared plus b squared over c squared. Well, I'm adding two fractions. My common denominator is c squared. So this equals a squared plus b squared over my common denominator, c squared. What does the Pythagorean theorem tell us that c squared equals? A squared plus b squared. C squared equals a squared plus b squared. So I can take a squared plus b squared and put it right in here for c squared. So I have a squared plus b squared over a squared plus b squared. And this is sine squared theta plus cosine squared theta. What's a squared plus b squared over a squared plus b squared? 1. I'm dividing some number, dividing it by the same number. So this tells me that sine squared theta plus cosine squared theta equals 1. This is the Pythagorean identity. For any angle, sine squared, if I square the sine of that angle and I square the cosine of that angle, they add together to give me 1. This is, along with the Pythagorean theorem, this is one of the most important identities in all of mathematics. This shows up everywhere in thousands of different places. Sine squared theta plus cosine squared theta equals 1. We were working on a problem in my Calculus 3 class today, and we used this identity. It shows up all the time. So this is an extremely important identity that we use in math. So this is our Pythagorean identity. For any angle, sine squared of the angle plus cosine squared of the angle equals 1, always. So questions on that? All right, so your homework, the way the homework is going to work is you will have several problems that have to do with this Pythagorean identity. So let me work through some of those. So we're using this Pythagorean identity. So the way those problems would look is the problem would say if the sine of h equals 0.67, what is the cosine of h? Well, our Pythagorean identity tells us that sine squared h plus cosine squared h equals 1. So I'm just going to plug my number in. Sine squared is taking the sine of angle and squaring it, so I get 0.67 squared. This is telling me to square whatever the sine of h is, plus cosine squared h equals 1. So I'm going to plug this in my calculator. 0.67 squared is 0.4489. So 0.4489 plus cosine squared h equals 1. I'm solving for, I want to figure out cosine h. So I have to get this cosine squared h by itself. So subtract 0.4489. And I get cosine squared h equals 1 minus 0.4489 is 0.5511. So cosine squared h is 0.5511. We want to find cosine of h, so what do we need to do? Square root. I think that's what you said.
Yeah.
So I get the cosine of h equals, and I take the square root of 0.5511. About 7.4, or 0.74. And let's look at this. This is sine squared, 0.4489. That's sine squared. 0.5511 is cosine squared. If I add those together, I get 1. Sine squared h plus cosine squared h equals 1. Huh? Because we had to find sine squared here, and we found cosine squared there, so they should add up to 1. If you get 0.99 or 0.98, you're probably doing the problem right. If you get 0.2, you know you've done something wrong. So sine squared of h plus cosine squared h equals 1. We're using our Pythagorean identity. Questions on that problem? All right, let's look at one more of these. Just want to make sure you understand the steps that we're using. And these are straight from your homework. So if you're writing these down, you'll have a couple of your homework problems done. If cosine v equals 0.5, what is sine v? We're using the Pythagorean identity. Sine squared v plus cosine squared v equals 1. So I'm just plugging in my numbers. Just like our last problem, sine squared v plus 0.5 squared equals 1. Sine squared v, 0.5 squared is 0.25 equals 1. Subtract 0.25. So I get sine squared v equals 1 minus 0.25 is 0.75. So we can check our answer right away. Sine squared is 0.75. Cosine squared is 0.25. 0.75 plus 0.25 is 1. So we know we've done it right. So I don't want sine squared, I want sine. So I take the square root of both sides. And I get that the sine of v equals 0.866. Cosine is 0.5, cosine of v is 0.5, sine of v is 0.866. Sine squared plus cosine squared equals 1. Using our Pythagorean identity. Questions on that problem? All right. A couple of your homework problems come from the book. So I wanted to do one of the problems from the book where you're using the identities without any numbers. So this is page 645, number 45. And what the problem asks us to do is simplify sine theta divided by tangent theta. So we want to simplify this. What they mean by simplify is write it in a simpler form. So what we do for problems like this is we're using our fractions to write our problems. So what did our tangent identities tell us? That the tangent of theta equals what? Sine theta divided by cosine theta. So I'm going to write tangent theta like that. So this equals sine theta divided by sine theta divided by cosine theta. When I divide by a fraction, it's the same as doing what? Multiplying by the reciprocal. So this equals sine theta times, I'm going to multiply by the reciprocal of this fraction, cosine theta divided by sine theta. This is just a fraction, this is just 1. What is sine theta divided by sine theta? 1. They cancel. They're the same, it's the same number. So this cancels. And all I'm left with is cosine theta. So to simplify, if I simplify this, sine theta divided by tangent theta equals cosine theta. So this is one way that we use trig identities to simplify our work. If we had some kind of problem and we had to do something with sine theta divided by tangent theta, I simplify that and write that as, I can go through this process and write that as cosine theta. So that's one way that you'll use this as you go further.
Yes, just what I was missing then, since say it was cosine beta over tan beta, would it just be what they have to be sine beta then?
So you're saying if we had cosine theta?
Whatever is in the fraction.
Not necessarily. Because this one, if I rewrite this, this is cosine theta divided by tangent theta is sine theta over cosine theta. I multiply by the reciprocal, so I get cosine theta times cosine theta over sine theta. And this comes out to cosine squared theta over sine theta. So this one doesn't simplify as nicely as this one does. So it's not as simple as just writing the missing part. There's more work to it than that. Yes?
Oh my god. That was so overlooked.
Our tangent identity tells us that tangent theta equals sine theta divided by cosine theta. This is the same as that. So I can just, where I have that written in my equation, I can just write that whole thing. So tangent theta is the same as sine theta divided by cosine theta. Those are the exact same thing. So I just substituted that into that fraction. That's where that came from. So we're just going to do just a very little bit with this. There are just a couple of problems that you have to do using this idea. Most of them have to do with the Pythagorean identity, like the other examples. All right, that's all we had for today.